Hi students, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody let me know in the comment section if I am clearly visible and audible to all of you or not. Yes students, am I clearly visible and audible to all of you or not? Let me know in the chat box. Yes everybody, am I clearly visible and audible to you? Yes. Let me just increase the brightness to yes. Okay. So in today's lecture, it's a very important lecture where we are going to talk about NERNST equation. We are going to solve questions on NERNST equation, and for sure one or two questions will be there on the basis of NERNST equation in your exam. Right? That's a for sure topic, right? Okay. So yes, in the last lecture, I gave you some homework and Rama Raju has done the homework. Thank you, Ramu. Then Srija has done the homework. Then Ashwan has done the homework. Tamiz has done the homework. Right? No, not the homework. Yes. So these are the students who have done their homework. So it is it is B and AC. This is what students are telling. So let's see. SOP, standard oxidation potential, is minus of oxidation potential minus of standard reduction potential, because see, standard electrode potential is nothing but reduction potential only. So oxidation potential is negative of the reduction potential. So answer is going to be B is the correct answer. And in the first thing, it is oxygen having positive standard potential means it is good oxidizing agent, good oxidant, bad reductant. See, positive standard oxidation, positive standard potential means positive reduction potential. That means it would want to get reduced. If someone wants to get to itself wants to get reduced, they will oxidize someone. They will be a very good oxidizing agent, right? They will be a very good oxidizing agent, right? Okay, everybody. Yes, students. Yes, Vansh. Very good evening, Mohammed, Rahul, Vansh. My blessings are always with you. Lucky, funny, yes. Thank you, thank you. Chalo. Now let us start the session, guys. That is NERNST equation, right? So to understand NERNST equation, understand one thing. What is NERNST equation? What we are going to calculate here. So there are two things, right? One is E naught cell, other is E cell, right? If I am saying that you are calculating E naught cell, so E naught cell is nothing but it is E naught cathode reduction potential minus E naught anode reduction potential. Okay, but if you talk about E naught's E cell, right, this is not equals to E naught cathode minus E naught anode. Reason, because E naught cell is the standard, that means at standard temperature, pressure, what is the value of E naught, right? That is your E naught cell, right? So here we can directly say E naught cathode minus E naught anode is your E naught cell, right? But when you talk about E cell, this is not in standard conditions, right? This has a different value, right? So when we calculate the value, the formula is very important, right? When you solve this, the formula will come out to be, this is, let's say this is the equation. Derivation and all is not important for you when we talk about a competitive exam, right? What is important for you? The formula, the applications. That's why the theory part in today's lecture is very less, right? Most of the things are questions. I'll solve a lot of questions for you so that you're able to understand how to apply this formula, right? This formula is easy to cram, but the application of this formula is very important, because there are so many ways you can do mistakes in this question, right? So I'll talk about every single type of question that they can ask you based on NERNST equation, right? So theory is simple, that this is the formula, that is E cell is equals to E naught cell, that is the standard condition, minus RTNF by ln Q. Q is the reaction quotient. Q is reaction quotient. What is reaction quotient? Reaction quotient is nothing but it is, the formula is same as equilibrium constant only, that is concentration of product raised to power the stoichiometry by concentration of reactant raised to power the stoichiometry. Here I am saying, let's say P is the stoichiometry, here R is the stoichiometry, right? So that is the reaction quotient, right? So this is going to be your full-fledged formula, right? That is E cell is equals to E naught minus RT NF ln Q, right? If you want to put it in log, then the formula will change here, right? If I want to put it in log, so this is another thing, that is concentration of solid or liquid component is one that you should always remember. If in the equation there is some solid or liquid component, pure solid or pure liquid, then the concentration of that thing is going to be 1. For gaseous components, concentration of pressure is equals to 1. That means we are saying for gaseous, if let's say this is also gas, this is also a gas, this is also a gas, this is also a gas, then instead of concentration you will write pressure of C, pressure of D, pressure of A, pressure of B, right? So that depends upon what kind of situation is given to you in the question, right? Now this formula is maximum what you will apply here, right? We know that E cell, or it is also called as EMF of the cell, that is equals to E naught minus of, we know that it was, let me just write it somewhere, it was coming out to be, it was E naught cell minus of NF minus of RT by NF ln Q. Now, when you replace natural log with log base 10, you have to multiply this with 2.303. You don't know the value of natural log. So, you will always solve it for log base 10. So, that's why this is the equation that you will remember. Now, if you put in the values of R is 0.8314, or you can say R has say 2 values. Here we are talking about EMF of the cell, right? Concentrations we are talking about. So, we'll take it as 0.0821, right? So when you put the value of R here, when you put the value of temperature, that is standard temperature, when you put Faraday is nothing but 96500. When you put these 3 values here and you solve this particular thing, that will come out to be 0.0591. And this is the final equation that you are going to use in all your formulas. That is E cell is equals to E naught cell minus 0.059, and sometimes it is taken as 0.06 also, divided by n log base 10q, right? This is the formula that you are going to use. Now, with the help of questions, I am going to teach you what are the different ways of applying this formula, right? This is not a theoretical topic, guys. This is a numerical based topic which you can only learn with the help of doing questions. Just by doing the theory part, you won't be able to understand this, right? So, I am having this first example, and with the help of examples, let's understand how to apply this formula, right? How to apply this N, how to calculate E naught cell, then how to calculate Q here, how to put it, that we will learn. See, if a representation is given to you, right? We know that if you want to know N value, right? That means N defines the number of electrons gained or lost in this chemical reaction. If you want to find the value of reaction quotient, you should know what is the product side, what is the reactant side, right? If you want to find the value of E naught cell, you should know which is cathode, which is anode. All these things you should be clear, right? So that we will learn here, right? If you see this particular equation here, I told you in cell representation, it is always AC. What is written here is always denoting anode. What is written here is denoting cathode, right? Now, if I talk about, ma'am, you are saying that it is denoting anode, then how to put it here, right? If this is denoting anode means this is getting converted from nickel to positive, right? And because it is 0 to +2, that means oxidation number is increasing. That means oxidation is happening in this case. That means it is losing the electrons. That is 2 electrons it is losing because charge is 2 positive here. Similarly, Eg positive is getting converted to Ag, right? Now, in this case, +1 to 0. 1 to 0, that means the charge is decreasing. So, whenever oxidation number is decreasing, that corresponds to reduction or oxidation. Everybody in the comment section, let me know. When the charge is decreasing here, if I say it is decreasing from 1 to 0, this is corresponding to reduction or oxidation. This is corresponding to decrease in oxidation number, that means reduction. That means here it will gain 1 electron. Now, I told you that number of electrons gained and lost always has to be same. So, I have to make this equal. So, what I'll do, I'll multiply this with 2, right? And this will become 2 of Ag positive plus 2 electrons give rise to 2 of Ag. And you will, when you will add this, right, 2 electrons cancel with this 2 electrons, you will have nickel plus 2 Ag positive give rise to Ag, 2 Ag plus Ni2 positive. This is going to be the final reaction. Okay. The first step is you should know how to write from cell representation to the reaction. Okay. If you are clear on that, how to write cell representation with the reaction, now you will be able to solve this question easily. First thing is, if you want to find the value of N, can you tell me what will be the value of N, guys? Number of electron lost and gained is 2. So, N value will be equals to 2, right? Now, what is the value? What is cathode? Tell me which is cathode here. Which is cathode? Cathode is silver. That means, and anode is nickel. Anode is nickel. That means you will subtract E naught of silver reduction potential minus E naught of nickel reduction potential. Okay, that is how you are going to subtract it. Then students, once we are done with this is cathode, this is anode. Another step after this is cathode, this is anode, this is nickel. Next step is going to be, ma'am, what is this reaction quotient? Reaction quotient is always product by reactants. So here product is, here this is product, and product we only talk about ions, okay? Because solid has concentration 1. I told you here only concentration of solid or liquid is 1. So that means you will take the concentration of Ag as 1. You will take the concentration of nickel as 1. So here this is your product, this is your reactant. You will see this is Ni2 positive, stoichiometry is 1 divided by Ag positive, stoichiometry is 2. And once you have already calculated these things, now doing the question is not that of a big deal, right? Now you can easily solve this. You just need to apply this formula. You can apply this formula. You can apply this thing here. That is, wait a minute. You can apply this formula, or directly you can apply this particular thing here. That is, E cell is equals to, firstly tell me what is E naught cell. E naught cell is equals to E naught cathode, right? E naught cathode. I think no value is given to you. So here you will write E naught of cathode. Cathode is silver, right? For silver, reduction is Ag positive to Ag minus E naught of anode, that is nickel. For nickel, reduction will be Ni2 positive to Ni, that is the reduction. This is oxidation, this is reduction. So you'll write the reduction potential here, right? Then you have minus 0.0591 divided by 2, that is N. This is log of Ni Na2 positive divided by Ag positive square. And in the question, they will give you the value of Ni concentration, Ag concentration, value of Ag electrode potential and nickel electrode potential. All these things will be given to you in the question. And that's how you calculate the value of EMF or E cell. Okay, guys. Let me know in the comment section in the chat box, Suman, Purva, Vansh, Mohammed, if that is clear to all of you or not. You can let me know in the comment section so that I can proceed with the questions now, right? So that I can proceed with the questions. You can let me know here, everybody in the comment section. Yes. Yes, everyone. Okay. Shall we move ahead? Right? This is done. Now, this is a proper question that is given to you. Right? Okay. Yes, we have another slide also. Let's calculate this. Okay. So, E naught cell is already given to you. Such an awesome thing. Na? E naught cell is already given to you. Right? Now, let's see if this is the representation. What is the reaction? Reaction will be, everyone, representation is given to you. You have to tell me the reaction here. Reaction will be, this is A part, this is C part. That means this is anode, this is cathode. It is losing the electron. So this will be Ag, 2 Ag positive. It is losing the electrons. That means here it will be 1 electron. This is cathode. It is gaining the electron. This will be Cu2 positive plus 2 electrons give rise to Cu. Now, to make this electron and this electron same, we'll have to multiply this with 2. So, I'm multiplying this with 2, right? So, once I multiply, I'll add this full-fledged reaction here. This will cancel out and you will have 2Ag plus Cu2 positive give rise to 2Ag positive plus Cu. This is your full-fledged reaction. Okay. Now tell me what is the value of number of electrons that it is exchanging. Right? Okay. Thank you, Vansh. So, number of electrons that it is exchanging here, gained and lost is 2. We have written it there. N is already we know. E naught value is given to you. Now, what is the value of Q? Reaction quotient. That is product by reactant. So, it will be Ag positive square divided by Cu2 positive concentration. And this is how you put it here. We know that E cell is equals to E naught cell minus of 0.059 by N log of QC. Or what is QC? QC is nothing but Ag positive square by Cu2 positive. Right? Now you have to put in the values here. So when you put the values of this thing, that is going to be E naught cell is minus of 0.46 minus 0.059 divided by 2. This is log of, let's have less space here, right? So this will be log base 10. Ag positive is this thing that is having 10 raised to power minus 3. And this is having Cu2 positive is having 10 raised to power minus 1. Right? When you solve this, you will get your answer, guys, easily. Right? Solving this, you will get your answer here. I'll just solve the value of log here because other things are just calculations, right? So this will be log of 10 raised to power minus 3 plus 1 is nothing but 10 raised to power minus 2, right? So when you solve this, this will be 10 raised to power minus 2, right? Now the power will come in the beginning, right? So in the front here, so it will be minus 2 log of base 10. What is log of base 10, 10? Guys, what is log of base 10, 10? 1. If you have not watched my video of anti-log log, please go and watch it. Now you can see how important it is. In chemical kinetics also, I told you that log is very, very important, right? Here also it is very important. So log is 1 only, so it is 0.46. 2 will cancel, this is 0.059, and solving this you will get your answer here, right? Okay, guys, now let's see the next one here. That is next question. Let's see this. Here they have given the reaction, so that is very sorted thing. They have already given the reaction. They are saying E naught of Mg is this, E naught of Ag is this, calculate E cell. Now E naught cell is not given to me. Now what I'll do, I'll firstly calculate E naught cell here. For that I should know which is cathode, which is anode, right? Cathode is the one which is gaining the electrons. If you see this here, in this case, Mg is getting converted to Mg2 positive. So oxidation number is increasing, that means oxidation it is. Ag positive is getting converted to Ag, that means oxidation number is decreasing. 1 to 0 oxidation number is decreasing. That's why it is reduction. So oxidation part is anode, reduction part is cathode. So can we say that E naught cell will be E naught reduction potential of Ag, that is cathode. E naught cathode is reduction. See, this is your cathode, this is your anode. So that's why you will write cathode minus anode. Now, second thing that you need to verify here is, have they given reduction potential only? This is plus 2 to 0. That means oxidation number is decreasing. That means it is reduction potential. Here plus 1 to 0. That means this is also reduction potential. That means in both the cases, reduction potentials are given to you. Because in both the cases, reduction potential is given to you. That means you are like, okay, ma'am, clear. Now you're clear on this part that reduction potentials are given to you, right? So what's the big deal? Now E naught of reduction potential of silver, right? Then E naught of reduction potential of Mg. Answer will be both the reduction potentials you need, and that is only given to you 0.80 minus of 2.37. That is 0.80 plus 2.37, right? That is going to be your value of E naught cell here, right? After that, you have E cell is equals to E naught cell minus 0.059 divided by N log of products by reactant. So product is this thing, reactant is this thing. So product, it is also called as oxidation by reduction. You can simply learn it as oxidation by reduction. Oxidation is happening for Mg, so you will write it as Mg2 positive. Reduction is happening for Ag, so you will write Ag positive. But in the balanced chemical equation, if you see Ag is having stoichiometry 2, so it will be 2 here. And this is your full-fledged formula, right, for this particular question, okay? Now, what is the value of N? Guys, what is the value of N here? 2 electrons. Here we know that it is losing, it is gaining 2 electrons. Here it is, sorry, it is gaining 1 electron. Here it is losing 2 electron. You will multiply this with 2 and hence you will have 2 electrons. That is, it is losing and gaining. So N will be equals to 2. So you can put it here. E naught cell, you can calculate it from here. 0, 8, 9, 10, 11. 3.17 is it? 3.17, 77 as it is. 8, 9, 10, 11, 1, 1, 3.17 I think so, right? So you will put it here. 3.17 minus 0.0591 divided by value of N is 2. This is log of Mg is nothing but it is the 0.130 divided by this is 0.00. I would say this is 1, 2, 3, 4. So it is 10 raised per minus 4. So you can write it 10 raised per minus 4 square. Right? You solve it and you will get your answer here. Right? Okay. Okay, everybody. Gaurav, the trick is practice. Practice as many as questions as possible and quality questions. Practice quality questions. Have not only cram the formula, practice things that how they ask you the questions in the exam. Do calculations till the end, right? You have to solve this part only. You can't leave it till this part. You have to do solve it till the end, till you are able to answer one of the answers of A, B, C, D. Okay? That you have to do. Okay, guys? Yes, everybody. Next question is, now this is slightly different question than what we did till now. This is find the relationship between pH of solution and reduction potential of SHG. Okay. So here what you have to do, reduction potential of SHG means hydrogen is a cathode. Hydrogen is the cathode. Right? That means what is happening here? Hydrogen is gaining electron to become H2. Reduction means gain of electron. Na? So that means hydrogen is gaining electron to become H2. That is only reduction. Right? Now, if it is gaining electron, if two hydrogens are formed here also, it should be two hydrogens. That means two electrons will be gained here. Right? Firstly, tell me, are you able to understand how I got a hint that this is the reaction that you are going to use here? Right? Now, once you know the reaction, everything else is very simple. Now, tell me, what is the E naught cell value for hydrogen? What is the E naught cell value of hydrogen? What is that? You will tell me. I don't need to tell you this. I know you are like well efficient to know this thing here. What is the E naught cell value of hydrogen? Waiting for your answers in the chat box. I am waiting for your answers in the chat box. E naught value for hydrogen. Very good. That is 0. Right? So, now when I need to solve this, E is equals to E naught cell minus 0.059 divided by N. What is the value of N here? What is the value of N? How many electrons it is gaining? 2 electrons. Right? So, you'll write it 2. This is log base 10 of product by reactants. Product side you have H2. Now H2 is a gas. It will not have a concentration. It will have pressure. It will have pressure. So you will write pressure of H2 divided by concentration of reactants raised to power stoichiometry, that is H positive raised to power 2. Right? Now, what is the value of pressure given to you? That is given to be 1. So you will solve it. 0 minus 0.059 divided by 2 log of base 10, this is 1. H positive concentration you don't know. So that, can you say it is H positive raised, because this is coming out to be 1. So this will be 10 raised to power minus 2. Right? Now solve it same. This is minus 0.059. I am not solving this. There is some reason behind that. Because this power will come in the front. And this will be log of 10 positive. Right? Now see this. Same thing I am going to write. Where should I write here? So I am going to solve it here. Right? I am going to solve it here. Right? So here it is. I am solving this here. It will be minus 0.059 divided by 2 will cancel. If I keep it here and I keep minus of log H positive, those who have done ionic equilibrium, those who don't have backlogs in ionic equilibrium, they know what is this. Minus log of H positive. What is this, guys? What is this? Minus log of H positive. Can you remember what is this thing? Ionic equilibrium. What is the formula of pH? pH is minus log base 10H positive, right? So this is the value of pH only, right? So you can say this is E cell is equals to, you can say this is minus 0.059, this is pH, right? Find the relation between pH of a solution and reduction potential of SHE. So here is the relation, right? So that is going to be, this is the relation. This is the relation, okay? That E cell is equals to minus of 0.059 pH. Clear, everyone? Is this thing clear to everybody? Own, it's so difficult. When we do it in our own, it's so difficult. Please say, ma'am. Yes, lack of practice, na? When you do it on your own, you just see that, oh my God, how to do it. When I teach you, I firstly tell you, sequence is same. Balanced equation, then E naught value, then N value, put it here, you will have your answer. Sequence has to be same, right? If the sequence is same, you will be able to do the questions yourself. Now guys, tell me if regarding this equation, it's not like I'm ending the question on that equation. We are moving further, you know. Earlier, they used to ask question based on simple this only, NERNST equation. Now, they have gone beyond NERNST equation. Value of E naught with delta G, E naught with equilibrium constant. This is all the things they are asking, right? So, we are going to talk about those kind of questions also, right? That is in NERNST equation only. That is the mean extension of NERNST equation, right? Now, if you tell me here you have any problem, then next step will be like ma'am, what you are teaching, I'm not able to understand anything. If right now also you have any problem, you can let me know. If that is clear to everybody here, you can let me know, ma'am, yes, it is clear, ma'am, move ahead. Right, ma'am, please move on from NERNST equation. Right, you can tell me in the chat box. Right, I'm waiting for your green signal so that I can move ahead. Right, green signal is green hearts. Right, if you give me green hearts, that means there is a green signal that yes, ma'am, you can move ahead. Okay, yes, everyone. Now let's see this. NERNST equation at equilibrium. NERNST equation at equilibrium. One doubt. What is the doubt? Let me know. What is the doubt, guys? Let me know. Only to one student it is clear. Other students it's not clear. Ma'am, we are very lazy, ma'am. What to do, ma'am? We are extremely lazy, ma'am. So, let me know if there is any doubt. You can let me know in the chat box. NERNST equation at equilibrium is, see, at equilibrium, E cell will become equals to 0. Okay. At equilibrium, E cell will become equals to 0. And your QC will become equals to KC. Okay. This is what happens at equilibrium. Right? There are so many other things that happens at equilibrium. That's why one of the relation that is this relation that is, wait a minute, E cell is equals to E naught cell minus 0.059 divided by N log of QC. This will change to, because this is equals to 0. So this will be 0 here. This will become Kc. So this particular equation will become E naught cell equals to minus of points, not minus, it should be plus. It will be 0.059 divided by N log of Kc. So this is the first formula that you will see here, which is a very, very, very important formula, right? This is a very, very, very important formula. right? Okay. Then if you talk about ma'am relation between, array, that is not a doubt that I am going to do now, right? So this is at equilibrium you have E naught cell is equals to 0.059 by n log Kc, right? Now let us see the next formula, right? That I'll teach you after, after some time. First you need to see this formula here. Yes, that is the next formula is, if you talk about Gibbs equation. So we know that delta G is equals to minus NFE naught cell. Okay. And delta G, this is for naught, this is minus NFE cell. This is another formula. This is a general formula. This I am not saying at equilibrium. This is a general formula that how Gibbs free energy and E naught cell are related to each other, right? So if you're taking standard Gibbs free energy, this is also standard. If you're taking general Gibbs free energy, this is also general. Now at equilibrium we know that E cell equals to 0. That means delta G will also be equals to 0, right? So can I say that at equilibrium, if these two things are equals to 0, then there is a relation, guys. Give me a second. Yes. Getting some call. Just give me a second. Okay. So sorry. Yes. Now, guys, now what we have, this is your E cell, this is your delta G. Now understand one thing, there is a relation between these two. How many of you know this relation? The relation is delta G is equals to delta G naught plus 2.303, right? This is RT log of QC. How many of you know this relation, everybody? How many of you know this relation? Everyone here, how many of you know this relation? Ma'am, what is G? G is Gibbs free enthalpy that we will study in thermodynamics, right? If you have done class 11th, you might have an idea about Gibbs free enthalpy. Otherwise, don't worry, I'm going to teach thermodynamics in class 11 classes. There you can get an idea about it, right? So Gibbs free energy is delta G. At standard condition, this is delta G naught. General condition is delta G. This particular equation you have studied from equilibrium chapter in your class 11, right? If you remember that, this is from class 11. Now, at equilibrium, we are saying that this is equals to 0. So, when this is equals to 0, this will become delta G naught plus 2.303 RT log of Kc. And Qc also become equals to Kc, na? Qc also become equals to Kc. So now can I say the final answer will be, delta G naught is equals to minus 2.303 RT log of Kc. This is your next relation between equilibrium constant and Gibbs free enthalpy. This was the relation between equilibrium constant and E naught cell. And both of these relations are very, very, very important, right? These two relations are very important, and this particular relation also in itself is very important. Okay, guys, any problem in this particular case? Chal. Yes, obviously discussions happen, only then some series starts, na? Okay, so Now guys, let us talk about this. We have done. Now let's talk about this thing, right? Other formulas na I have already taught you, right? So there is no need of going through that, right? This also we have done, this also we have done, right? All of these we have already done. So just remember what I have written here, right? Now, next question is, ma'am, you are saying equilibrium, 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 but how equilibrium is achieved? Okay, let's talk about that. See, one very simple thing. I don't know what has happened to my motor functions today, right? I think I'm too tired by taking classes. Maybe because of that, it's again and again slipping from my hands. Okay, so reduction potential and time, basically we are going to talk about. See, if you talk about as time increases, we know that reaction is proceeding more and more, right? So how reduction potential of anode and cathode increases or decreases, right? So always remember the reduction potential of anode always increases and the reduction potential of cathode always decreases. Now you will ask me, ma'am, how you can say it is always increasing and decreasing? See, let's see this from the equation, right? E cell is equals to E naught cell, which is a constant value, 0.059 divided by N. N is also constant. Log of concentration of this is product. Basically, this is for oxidation. This is for reduction. This is how the reaction is, right? Because from here, theoretical question can be asked. Okay. Now, this is constant. This whole term is constant. This is constant. This is constant. This thing is not constant. And this thing is not constant. Right? So, when reaction is proceeding, we know that product formation is increasing. That means this value is increasing. This value is increasing. When this particular value is increasing, right, the whole value will increase. That means this whole value will decrease, right? That means here we are calculating the reduction potential. So that means the reduction potential here will decrease, right? Okay. Now, that's why and if you talk about for cathode, that's why for cathode what happens, this is decreasing. But for anode, it is opposite, right? For anode, what is happening, right? So, because for cathode, the reduction potential is decreasing. For anode, it will increase, right? Because if you, this simple thing is, if you're talking about one reduction potential, for cathode, it is decreasing, right? As the time is moving, for anode, it will be opposite, right? So that's why for anode, what will happen? It will increase, right? So that's how from this equation we can get an idea that always and always as the reaction is proceeding, for anode it is increasing, for cathode it is decreasing, for cathode it is decreasing. Okay? Okay, yes. Now, beta, please focus in the class now. If you keep moving like this, then the syllabus will not be completed. Okay? Yes. Now, let's see this thing here. The standard EMF of Daniell cell is 1.1 volt. Maximum electric work obtained from the Daniell cell, they are asking you. See, electric work is nothing but it is minus of delta G. Now, what is delta G? Delta is minus of NFE cell, right? Now, they are saying standard EMF of the cell is given to you, that is 1.1. Standard, that means E naught cell is already given to you, right? So, we can say minus of, this is nothing, it will become NFE naught cell. This is your work done. So, it will become how many electrons it is gained? Maximum electric work from Daniell cell. See, we know that last time we did Daniell cell, right? In Daniell cell, number of electrons gained were 2. It will be 2, 96500, and this is E naught is 1.1, and this will be your work done here. And this is going to be your work done here. Right, everybody? Okay. Next is applications, like how the Gibbs free energy of the reaction is going to tell you the, like if you are able to calculate, let's say E naught is given to you, right? E naught is given to you. Simple thing is, if E naught cell is positive in nature, from this equation that delta G is equals to minus NF E naught cell, that means delta G will be negative. If E naught cell is negative, then delta G naught will be positive, right? Now we know that from thermodynamics that if delta G is negative, it is a spontaneous reaction. That means it will occur by itself. It is a feasible reaction. But if delta G is positive, it is a non-spontaneous reaction. It is a non-spontaneous reaction. Tell me, student, if that is clear to everybody or not. Right? Okay. Let me know, students, in the chat box if that is clear to all of you or not, so that we shall move with the next question here. Right, everybody? Next question on your screen we have here, right? We have here. That is again what they are asking, what they have given, what they are asking. Let's see that. So some equation is given to you. Reaction was conducted with ratio of this and this. Okay. The pH value which the EMF of the half cell becomes 0 is. That means they are saying EMF E cell will become 0. You have to calculate the pH of this. Right. So let's see how to calculate. Students, first thing is, let's write down the formula. What is the formula, guys? What is the formula? Formula is E cell, which is given to be 0, is equals to E naught cell minus 0.0591, or you can just say 0.59 divided by N log of reactant, log of product by reactant. This is product and this is the reactant, right? And this is also the ion, this is also the reactant. So what you will do here, that means it is going to give you 2-3 things here. That means it will be product is this thing, that is Cr3 positive. So it will be Cr3 positive. Is there any stoichiometry here? It is square here, right? So we'll define here square divided by reactant is this and this. So it will be Cr2O7 2 negative multiplied by H positive raised to power 14. So it will be Cr2O7 2 negative divided by reactants now. 2 negative, wait a minute, 2 negative concentration. Here also it was concentration, right? And here it is H positive concentration raised to power 14. Because in the balanced equation, 14 is the stoichiometry here. Number of electron gained is 6, so N will be equals to 6 here, right? So you can put the value of N here, that is equals to 6. And here E cell is given to be 0, so you can put the value here 0. Now, if you see, 2 things we have to see, that Cr3 positive square divided by this particular thing is already given to you in the question, that is 10 raised to power minus 6, right? So can I write it here? Can I write it here? E naught cell. Can I write it here? E naught cell is equals to 0.059 divided by 6. This is log 10 raised to power minus 6. This is H positive 40. This should be minus of 40, right? Now, can you tell me what is the value of this E naught cell? What should be the value of this E naught cell if you see? See, E naught cell value you have to calculate here. This thing is given to you, right? Now, for E naught cell, you need to know which is the reduction, which is undergoing oxidation. If you see this, from here to here, in this case, what is the oxidation state? 2x minus 14 is equals to minus 2. 2x is equals to, oxidation state is in redox reactions. Okay. So this is 2 into x. Chromium, I am taking it as x. For oxygen, it is minus 2. So 7 into minus 2 is 14 is equals to minus 2. So it will become x is equals to plus of 6. So here it is plus 6 and here it is plus 3. Now tell me, is the oxidation number decreasing or increasing? Oxidation number is decreasing or increasing? It is decreasing here. That means this is a case of reduction, right? This is the case of reduction here. And if you talk about this thing here, this is plus 1. This is going to, if this is a case of reduction, this should be the case of oxidation. It has to go to 0 only, right? Yes, that will be a case of oxidation only, right? So we can say that in this case, standard half cell reduction potential, E naught, for this full cell is already given to you, right? So what you will say, it is E naught cell is equals to E naught cathode minus anode. This is cathode, that is given to be 1.33. Anode is hydrogen, that is 0 only. So it will be equals to 1.33. E naught cell also we have calculated, that is given to be 1.33. Now when you put the value of E naught cell here, 1.33, tell me beta what you are left with. This is log of 10 raised to power minus 6 plus this is log of, because this is multiplication, log of m multiplied by n is log of m plus log of n. So this is log of m, this is log of n, that is 10, this is minus 14. Those who are not able to understand this thing, that means your log anti-log is weak. Go and watch that video, right? So this is 3. So after this, what you will do? 1.33 equals to, this will be minus 6. This power will come in front and log base 10 of 10 is 1 only. This power will again come in front. So this will be minus 14. This is log of 10 H positive. Now if you see this, this is 1.33 minus 6 plus 14 minus log of H positive. I have just rearranged this thing here because minus log of H positive is pH, right? So this will be 1.33 plus of 16 is equals to, this is divided by 14 is equals to pH. That is how you're going to solve the value of pH here, right everybody? Hello Raju, Rama, yes. Yes, I will confirm you in the end, okay? Yes, now focus on the board, right? Let me know guys if this is clear. This is your JEE Mains 2025 question, okay? Let me know in the chat box if that is clear to all of you or not, right? This was based on, you can see this here, that you will calculate easily, right? Okay? Have I forgotten about point? Oh, I forgot about point 059. I forgot writing 0.059 by 6. I just solved this thing here, right? This will be, you can do this thing here. This will be 1.33 multiplied by 6 divided by 0.059. 1.33 multiplied by 6.059. You can say this will be 1.33 multiplied by 6 divided by 0.059, or you can say 0.06 plus of 6, then it is altogether divided by 40, right? That will be your pH. Okay, it's all a game of calculations, right? Calculate this term, add this here, divide it with 14, you will have your answer, right? Okay, everybody. answer will be there. That will come out around 10.08 will be your answer. Right, everyone? Next question, let us talk about that. That is 2024 question that is based on a reaction is given to you. See, can you see it? They are relating this with like DNF block, like difficult, not difficult calculations. Yes, difficult calculations are given, but also the reaction also, they have not given simple reaction that they used to give, right? Now, they are giving that this is the equation. E naught of Mn is this, E naught of C is this. We don't know which is anode, which is cathode. Equilibrium constant we have to calculate. That is going to be 10 raised to power x. You will tell what is this x value here, right? For that, firstly, you should know what is anode, what is cathode. How do you know what is anode, what is cathode? For that, you should know the oxidation numbers here. That you will learn in oxidation, that you will learn in redox reaction. So here it is x minus 8 is equals to minus 1. That is nothing but plus 7. This is plus 2. Here oxidation number is decreasing. So this is reduction. That means it is cathode. So we can say this is your cathode. Then oxidation, here we know that this is x minus 4 is equals to 0 because oxygen is minus 2. So it will become plus 4. And here carbon is nothing but, in this case carbon is plus 2 is for hydrogen, plus 2x is for carbon, minus 8 is equals to 0. So 2x is equals to 6, x is equals to plus 3. So that means this is going to be plus 3 and here it is increasing, right? So can you see in this case, in this oxidation is happening. That means this is the anode part. This is the anode part here. Cathode you know, anode you know. Now how to calculate the E naught cell? E naught cell is nothing but it is E naught of cathode. Here plus 7 to plus 2 is given, that means reduction is given. Here plus 4, this is plus 3 is given, that means reduction potential is given. So directly put the value cathode minus anode is 1.51 minus of 0.49. And here it will be 1.51 plus 0.49 will be your value of E naught cell, right? Next is how many electrons it is gaining or losing. If you see plus 7 to plus 2, then there is plus 3 to plus 4, right? Here the change is 5, here the change is 1. So here this will also be multiplied by 5 to make the electrons equal, right? The difference is the amount of electrons added or gained, added or lost, right? So that means N value is going to be 5 here, right? So this is the value of N here, this is the value of E naught here. Sorted. What else you need? What else you need? Just put it in the formula. E cell is equals to E naught cell minus point, and they are saying it is at equilibrium now, so it will be very simple. E naught cell is equals to 0.059 divided by N log of Kc. Simple. E naught cell we have calculated it here. That is, this is 9, 1.51, 0.49, this is 10, again 10, 2 will be the answer. Right? Okay. I say you could have calculated this though, right? So this is 2, this is 0.059, this is also 2, this is log of Kc, right? Calculate this, this will become 4 divided by 0.059 will be your log of Kc. Now Kc, you will take Kc will be nothing but anti-log of 4 by 0.059, and that's how after taking anti-log you will have your answer here, right? Wait a minute. N will not beat 5, guys. N will not be 5. No. Why so? Because I missed this thing here. C2. I missed it there, right? Acha, listen one thing. While you are calculating N, see this thing here. See, This is plus 7 to plus 2. That means total oxidation number is decreasing. So it is gaining 5 electrons here. If you talk about carbon, for one carbon it is plus 3 to plus 2. Sorry, plus 3 to plus 4. That means it is losing 1 electron. This is for one carbon. But here you have 2 carbons. So you have to do it for 2 carbons. So for 2 carbons, it will be multiplied by 2. So it will be 2. It will be 2 means this will become plus 6 to plus 8. Not exactly this thing. It will exactly become, if you see the difference here, that is 1. When you multiply this with 5, that will, for one carbon, 5 electrons are gained or lost to make this equal, right? But now here we are talking about 2 carbons, right? So 2 carbon means this will be further multiplied by 2 and hence it will become 10 electrons gained or lost. So here also you'll have to multiply this with 2 because here also we need 10 electrons. So that's how N will become equals to 10 electrons, not 5. Okay, so you have to take care of this thing, that how many carbon we are taking here. Carbon is 2 in this case. So we have to talk about 2 carbons, not 1 carbon. Okay? Yes, everybody? Yes. See, this is a part of redox reactions. This is a part of electrochemistry. That's why redox reactions and electrochemistry go hand in hand. Right? So if you're not clear on this part, we will study this in redox reaction, balancing also we will study. There you will get more clarity on how come it has 10 electrons. Right? So when we are talking about, see here Mn, here is also 1 Mn. That's why I have not touched Mn. But here this is 2 carbon, this is 1 carbon. That's why I have to talk about 2 carbons here. Right? Okay? Yes, everybody? Yes, everyone? You can also learn it. You can also not learn it. You can also understand it this way, that this is plus 3, this is plus 4. This is for 1 carbon. It is losing 1 electron. For 2 carbon, it will be losing, see, you can say one thing. For 1 carbon, it is losing 1 electron. For 2 carbon, it will be losing 2 electrons. Right? Because if here, this is the idea for 1 carbon, this is the idea for 1 carbon, then for 2 carbon, this will become plus 6, this will become plus 8, and this will become, how much is the difference? 2 electrons. So it is losing 2 electrons. Understood? So now this is 5, this is 2. So that's why I multiplied it by 2, I multiplied it by 5. That's how N became 10. Clear, everybody, or not? Tell me in the chat box. Guys, I was thinking of doing a lot of questions, but I'm thinking that now I should not do those many questions because clearly you guys are not at all interested as usual, right? This is a stupid person here at 10 p.m. teaching you like a stupid person, right? Because there is no benefit of doing that. Clearly, I can see that, right? Chal. ठीक है, नहीं समझ आया, it's okay. What I can do, I can only ask you again and again. If you're still not answering anything, I can't do anything, right? So totally your choice. You want to answer, perfect. You don't want to answer, perfect. So the hydrogen electrode is dipped in a solution of pH is equals to 3. pH is 3 given to you. The potential of electrode will be dash. Potential of electrode they are saying. See, simple thing is, again you have to use the same formula, right? See, this is the hydrogen electrode. This we did like before we did the derivation also. Now they are talking about the dipped in this particular solution. So that means pH is given to you. Now this is the formula, right? E naught value, we know that this is equals to 0. 2 electrons are gained. So here we have put it 2. Product is H2. So here I have used pressure of H2. Reactant is H positive. So it will be H positive raised to power 2, right? Now when you solve this, instead of writing this directly, how we can write it here, that is how you will solve it here. Directly you can say that E cell is equals to minus 0.059 divided by 2. pH, pressure of hydrogen is 1, right? Pressure of hydrogen is 1. If it is not 1, it is given to be 3. So you have to take it 3, right? Pressure of hydrogen is given to be 3. Okay. H positive, we have no idea. This is H positive raised to power minus 2. So how you will solve it? E cell is it given to you? E cell is given to us, that is the pH is given, the potential of the electrode. pH, pH this is given to you. I thought pressure is given to you. Wait a minute. Okay. Pressure will to 1 nahi hai na. If nothing is given, we will take it as 1. Nothing is given regarding pressure of H2, so that is 1. Right? So now if this is 1, this will become log of H positive minus 2. Right? Now E naught value they are asking you, pH they have given to be 3. It will be minus 0.059 divided by 2. This will come here. This is minus 2 log. I have also solved derivation for you directly. You can also do that way. You can also do this way. This will be H positive. 2 will cancel. E cell is equals to 0.059. This is pH. Why? Because minus of log H positive is pH. So that's why E cell is equals to 0.059 multiplied by 3. That is going to be your answer here. Right? Okay, everybody. That is going to be the answer here. Now, this is actually a different question than what we have done till now. This is JEE Mains 2023 question, and this was asked in, these kind of questions were asked in attempt 1 also, 2024 also, right? It's very repetitive. Nowadays, it's a trend of these kind of questions, right? So now what they're asking you here is, for that you need to understand one concept, right? The concept is that, for example, this is A3 positive. This is converting to A2 positive. This is converting to A positive. Then let's say here number of electron involved, and here directly if I say A3 is converting to A positive. Here let's say number of electron is N1, number of electron is N2, here number of electron is N3. Here electrode is E1, here electrode potential is E2, here electrode potential is E3. Now the formula, we always say that when this kind of situation is given to you, right? And they ask you electrode potential, they have given E1 is this, E2 is this, calculate E3. You can't just calculate E3 is equals to E1 plus E2, because electrode potential is not at all additive in nature. But electrode potential is not additive in nature, but Gibbs free enthalpy is additive in nature. So that is the reason we calculate it this way. This will be N3 E3 is equals to N1 E1 plus N2 E2. So if they ask you any of the value, they ask you E3, they ask you E2, they ask you E1, you can calculate by Gibbs free enthalpy, that is additive in nature. Now ma'am, how can you just write delta G is equals to NF? No, delta G is not equals to NF. This is minus NF E naught. This is minus NF, this is N2, this is N1, this is E1, this is minus N2 FE2. Now minus will cancel, right? And Faraday will cancel. So in the end you have E3 N3 N2 E2 plus N1 E1. Okay everyone, is that clear? Yes. E is not, yes, Sohid, absolutely right. Very good that you remember it from thermodynamics. That's a good thing, right? So this is your final thing. Now we are going to see how we are going to apply it in the question, right? How, ma'am, exactly it is applied in the questions. Okay, same thing I'll apply in the question here. That is, here the question is, you have PB positive, PB2 positive, these things you have. So I'll write it as PB, I will always write the reduction potential. So for that, I have to decrease the oxidation number. So I'll write it with the maximum oxidation number, then less than that, then less than that. So PB4 to PB2 positive I have written. PB2 positive to PB it is there. Then PB4 to PB. That means this thing is there. So you write it this way, it will be easy to answer the questions, okay? So here I know how many electrons are involved. 2 electrons. How many electrons are involved? 2 electrons again. How many electrons are involved? 4 electrons. 4 minus 2, 2. 2 minus 0, 2. 4 minus 0, 4. Electrons involvement I have seen. Here from 4 positive, you should know the reduction potentials, okay? Write down the reduction because here I am writing the reduction potential. This is not reduction potential. This is oxidation potential. They are asking oxidation potential. This is oxidation potential that is given to you. This is the reduction potential. This is the reduction potential. Because here the oxidation number is decreasing. So this is oxidation, this is reduction, this is reduction, this is oxidation, what they are asking you, right? So here, if you see reduction potential from 4 to 2, they are asking, this is the question mark. Firstly, I will answer reduction potential, then I will convert it into oxidation potential, okay? This is a question mark. This is given to be M. 2 positive to this is given to be M. This is given to be 4 positive to this is given to be N, right? This is given to be N. Now, if you solve this here, we know that N3, 3, that means this N is 4, E3 is N, is equals to, right? So, this is 2 into X plus of, this is 2 into M. Very simple, right? So, how do you calculate it? Divide it by 2, it will be 2n. This will be x. That is 2n minus m. This is the value of reduction potential. Because here I am saying that 4 positive is getting converted to 0. This is the reduction potential. This arrow, you have to see the arrow here. 4 positive to 0 is easy of oxidation potential will be minus of x, that is nothing but m minus 2n. So answer is going to be m minus 2n. If you compare it with this thing, m minus, you'll say, ma'am, x is this, ma'am, x is that, ma'am. Hai So y is coming out to be minus of y, that is coming out to be m minus 2n. When you compare it with m minus 2n, then comparing it is 2023 question. Let me know, guys, if that is clear to everybody of you or not. Then again, next question is JEE Main 2023. That is number of incorrect statements from the following you have to tell. See, electrical work that a reaction can perform at a constant pressure is equal to reaction Gibbs free enthalpy. Correct? Yes. W is equals to delta G. It is Gibbs free enthalpy. E naught cell is dependent on pressure. Is it? E naught cell is dependent on pressure. Where have you seen in the full NERNST equation there was any term of pressure? No, this is the incorrect statement. We have our answer. Then d E naught cell by dt is equals to delta S NF. This now you will study this. Actually, chalo, just learn this particular equation. This is the correct equation. This is actually the correct thing. That is when you integrate E naught cell with temperature, this is going to be entropy by NF, right? Now, next is, this is actually true, right? Don't worry, we will study this further. A cell is operating reversibly if the cell potential is exactly balanced by opposing source of potential difference. A cell is reversibly if the cell potential is exactly balanced by opposing source of potential difference. The cell will stop. Cell is exactly balanced by opposing source of cell potential. Wait a minute. Opposing reverse belief, cell potential is exactly balanced by an opposing source of potential difference. The cell is not reversibly, it is actually stops. The cell will stop. So I think B and D also should be the incorrect answer, because the cell will stop. If it is exactly the same, then the cell should stop, right? Reverse means the external voltage has to be more than the voltage of the cell. Then the cell will behave reversibly. Okay. Now the last question of today, that is JEE Mains 2023 question. Let us see that. Let us see if you are able to do this or not. Okay. So logarithm of equilibrium constant of this reaction is given to you guys. This reaction is also given to you, right? They are asking you for this particular reaction. They have given you E naught of this reaction and this reaction. If you see this here, in both the reactions, what is happening? PD2 positive is getting converted to PD, right? Then here PdCl4, this is getting converted to this thing. Okay, you have to make this reaction out of it. See, it's a thing of combination and reverse. It's that from these two reactions, you have to make this reaction. Simple thing is, PD should be on the reactant side and this PD solid should not be there. That means this and this should cancel each other. That means what I'll do, I'll reverse this equation here. This will be PD solid plus 4Cl negative equals to PdCl4 2 negative plus 2 electrons, and this will be PD2 positive, PD2 positive, okay, plus 2 electrons give rise to PD solid. So when you add this equation and this equation, you will form an equation where this 2 electron will cancel, PD will cancel, and you will have this particular answer, that is PD2 positive plus 4Cl negative give rise to PdCl4 2 negative. Right? Aren't we forming the same equation? We are able to form the same equation, guys. Yes, even I feel. Nana, you are also working very hard, right? I'm just trying to, do as much as possible, as much as I can teach you, so that the students who are sincere, at least they can get something out of this lecture, right? And I promise that even if you do the questions that I have explained you here, your topic is done. Else you just need to practice, right? Everything I cover in my lecture, right? So you need to worry about that. Now, this and this is done. Now, are you able to see this kind of question also they can ask you? Here, you have to reverse this reaction. If you reverse the reaction, E naught will also be reversed. That is minus of 0.65 volt. Okay? So, you are adding these two things here. Right? Or you can solve it other way around also. Firstly, tell me, what is the value of N here? Number of electrons were 2, so you will say N is equals to 2. Okay? Now, if you see what is the value of E naught cell here, that is going to be E naught cathode minus anode. Which is behaving as cathode? This part is behaving as anode. This part is behaving as cathode. It is gaining the electron, it is behaving as cathode. So firstly, you will see cathode means this particular part. The reduction potential of this part is 0.83 minus of reduction potential of anode part. This is your anode part. PD4Cl, this is your anode part. And this is the oxidation. This is oxidation is happening. It is losing 2 electrons. This is the reduction potential of this anode part, right? So that's why you will subtract minus 0.65. You can do this, or you can say when you are inversing the reaction, electrode potential is also inversing. So you add this electron potential and this electrode potential, you will get the same result. That is your E0 cell. Okay. Now last part is to understand what is QC. What is QC? If you see this here, what is the value of QC, guys? Reacting products by reactant. Product by reactants is very simple. How do you answer that? Yes, everyone. I think they are asking you the equilibrium constant only. QC, then you don't have to apply, right? Simply what you will do, E0 cell is equals to 0.059 by n log of Kc. That is 0.059 by 2 log of Kc. You have to answer. E0 is minus this. So 0.83 minus 0.83 minus 0.65. 13 minus 5, 5, 6, 7, 8. 76.18. Right? I hope so. I'm calculating right. Calculation I always have doubt on. Okay? 2 multiplied by 2.059, and this, after this, calculating this, take the anti-log here and you will have your answer. Okay? Okay? Beta, by solving questions, you get rid of the problems. This all, I've already told you how to solve this. Done, 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 done. Log K will come out to be 6 after solving. Now see, after solving this, they are saying that it is coming out to be 6. Now tell me, whenever you take anti-log, Kc is nothing but it is anti-log of 6. That is nothing but it is 10 raised to power 6. Okay? That is nothing but 10 raised to power 6. So you can see this here, answer will be 10 raised to power 6. Were they asking you log value or anti-log value? They were asking you log value only. They are asking you logarithm of equilibrium constant. So log K is coming out to be 6. Okay? Everybody, see, we have solved this, and you know, the amount of questions that we have solved is all what you will get in your exam. These are the kind of questions. But for that, you also need to practice you yourself have to practice a lot of questions, right? If you're not practicing, then I really doubt if you will be able to get into your seat, like your dream seat or not, your dream college or not, right? If you really want to get it, practice as much as possible. There is nothing better than practicing questions, right? So guys, this is your homework. First homework, what is oxidation potential of hydrogen electrode containing a solution of pH 4? Next is calculate the EMF of the following. This is your homework number 2. And I'll see that if you guys are answering this in the comment section or not. And guys, this is our official Vedantu JEE English Telegram channel, right? And I would love to see your answers in the comment section regarding these 2 questions here, right? And guys, if you see this in the description box, you will see Sigma JEE 2026 batch, where these kind of sessions are conducted, right? We are solving as much as amount of questions that we can solve in that particular class, from Tattva modules, that is Vedantu modules, from quizzes, leaderboards, and after the classes also DPPs are provided to you. Then after DPPs, Tattva questions are given to you, solve these particular questions. Then after solving of those questions, it's not only there. We take proper Tattva sessions for question solving, right? And also guys, mock tests are taken after every 2 weeks, that is after every 15 days. Test series are provided to you. So everything is there in this batch, that is at 4999. You can see this here. This is your view course plan. If you're ma'am, I need this batch, then go for 4999, right? If you're ma'am, I need this batch, but along with that, ma'am, I also need these kind of short notes, right? Quick revision cards. If you also need this, then you can go for 5999 batch. If you want that, ma'am, I also need JEE 11th and 12th books in hard copy. See, books will be provided here also, but that will be PDF form. If you want hard copy form, right, like you have books, right, so that will be available at 8999, which will be delivered at your home, right? So that's totally your choice what you want, right? And that's it for today, students. This is the batch, and right now in the batch, redox reactions are going on in detail, like questions, tattva solving, everything is going on there. So it's so much fun, right? And yeah, that's it. Okay. Chalo. Okay, then. Hard. If I say for someone exam might be hard, for someone exam might be easy, right? So that depends upon your level of preparation, right? Okay, that depends upon that thing. But as compared to JEE Mains, it is like not above that, it is maybe equal or little bit below, right? Chalo. Okay then, students, practically the batch questions. Next class while practicing the batch questions. Yes, yes. Okay, done, Vansh. Okay then, students, bye-bye. Take care. Now do your homework in the comment section. I'm waiting for your homework in the comment section. Then till then, bye-bye. Take care. See you all in